Write nicely. FRS, right? FRS is called alkanes. Okay, alkanes is only your bromine, okay, like, or chlorine, UV, like this one is straightforward. Most of the time chlorine now. Bromine if one is a liquid, chlorine is a gas. This one finish, one box enough. Okay? I try to squeeze in this whole page, can one page only, right? Okay. Next one is your electrophilic addition, is your alkenes, right? Alkenes, what is it? So, okay, this is only one. This one is bromine liquid in CCl4, right? And the friend is bromine aqueous. And the friend is dry, right? Dry HBr gas, because if it's wet, it's a hydrobromic acid, no link, totally wrong. And the last one is water, but you must say cold, concentrated H2SO4 followed by boiling. Okay, no, I think boiling only one scoop. Heating with water, can? Heating with water or steam, enough become steam. Finish. Right? Okay, important. This page is the most important already. At least you know all this. But the sad truth is sometimes you know all these, they never test any one of them. No, sure test one. Okay, but some application, you must know the question is hinting you one of these. Later I'll show you an example. Next chapter is what? Electrophilic substitution, Arenes, right? So also got 4. So 1, 4. Later I write number big. What's the first one? So 1, 2, 3, all the same. Cl2 or Br2, okay, Cl2 halogenation or Br, okay, or Br2, hold on, then same, C, okay, don't say C, R, right? It can be a RCl and a RCOCl, right? So these three exactly the same, you know why? These three, I can bracket like that, like easy, anhydrous, FeCl3, FeBr3, AlCl3, AlBr3, sometimes Fe and Al. Very rare, normally it's the first 4. Room temperature.
Is CL only cell or Br? It's only cell.
Both. What do you mean? The Br2 and Br2?
RCl and
okay, can be Br also. Because it's a halogen that they want. So of course RCl or very rare like RBr can, then this one also can be a Br, COBr. It's a constant looking at it, very scary. So I put these 3 in the same, using purple in the same color, right? Because they are the same. It's just a different thing, but the reagent and conditions are the same. You understand? Then the 4th one is what? Concentrated HNO3, concentrated H2SO4, 55 degrees Celsius, right? Nitration, right? All these, not today. Today, remember what? You leave the class here very good, if you're happy, but remember, 1, 2 days later, just take out this paper and look again, or you redesign at home, paste on the wall. Last time, one student paste toilet bowl, paste in the ceiling, paste on the bed, paste on the toilet. The toilet, oh, she very high level, what? Hey, high level. She laminate the toilet, it will be wet, what? She laminate paste in the shower, Of course, 4A, but don't need to extreme, I don't extreme, paste a mirror, so I go, what all looks one. Okay, she don't forget, but of course, A, the happy is 4A, and now she's for doctor, See, yes, 144. Clear not? Hey, hello. 1, 4, 4, right? Next one is what? Next one is your. Next one. Wait, let me see what color. Next one is what? Nucleophilic sub, right? Under halogen. Right? 3 only. Right? Only got 3. 3. What's the 3? You guys remember any or not? At least. Okay, there I think a second. Okay, hold on. NaOH equals heat. Even is the first one, easiest of all, don't forget. Take the Cl, put the OH in there. Okay, OH minus is a nucleophile. NaCN or depend on school, so NaCN or KCN, right? Or KCN. And this one was like ethanol, ethanol medium and heat, or ethanolic KCN, alcoholic KCN. All these are different words. This is the CN minus. Okay, the CN minus, huh? Last one. No, that's elimination, not right here. That's not nucleophile. The last one, the most irritating of all. Huh? No, that's reduction. The last one for all this is just the mechanism, like the nucleophile, electrophile. There's other things. No, not today. That's the last one. Most irritating of all. Concentrated excess. What? Alcoholic. What? Who? NH3, right? Heat in a cube. Ayo, I'll squeeze the last one here. There's no space. No meaning fact. Let's stay on page 3. So 3 lah. Okay, this one got 3. The last one is 1, which is today's chapter. So all these are the 3 nucleophile lah for the nucleophilic sub halogen. Then kick away Cl, put in the new guy. Right, sub is a substitution. Last one today is called nucleophilic add, which is called carbonyl. So why I say I like, because only 1. The rest got 4, 3, 4, this one 1 only, right? 1 is what? HCN, trace. KOH. I mean, it can be NaOH. Or trace KCN or NaCN. Cold. Finish. I'll tell you the reason why I need to trace that. So this part here is the OR, not both. Either you trace KOH or trace NaOH or trace KCN or trace NaCN in the cold conditions. This is the page that you should print out, write nicely, paste somewhere. Just know this. It will give you quite a lot of marks. No, or so everything is or. Choose one. So depends on school. Some school they introduce 1, some introduce 2. So follow a school. But I will teach you today what's the reason of all these traits and when to use what, which is today's class now. So nucleophilic addition belongs to carbonyl, and carbonyl consists of what and what? Then what is it? I know you never watch lecture. Oh, no, it's correct. But anyway, it doesn't matter. Your mother won't see this. It's not carbon, Yes, the CO, what's the name? Not Esau, L. Did you watch lecture? Oh, okay, I better pause a while. I need to motivate you a bit. So what's the difference between these two, right? So let's realize how to draw an aldehyde and ketone. Okay, I'm going to teach as though nobody learned this before, right? So aldehyde is CO, at least got 1 H. This one can be R or H. Ketone, both R. Aldehyde, at least 1 H, can be both H. Ketone, cannot H. Again, which chapter you see this word aldehyde and ketone before? Hopefully some chapters. Very good. Oxidized halfway, something like okay, very good. At least have some impression. But the one you cannot talk about it, it's all recorded. Now, listen to me, everybody. Now, so nucleophilic add, the condition is what? HCN. Remember, I told you got so many traces. Okay, write all the traces. Trace NaOH, can be trace KOH, can be trace NaCN, can be trace KCN, cold. Trace. Trace is what? What's the meaning of trace? A bit. Okay, now let's analyze the mechanism. Listen properly, okay? Listen properly. The mechanism is like that. Okay, let's say I put a ketone, doesn't matter. Okay, plus what thing? Can remember? Since you watch lecture, plus what?
What you say?
No, he's saying. Plus what? The first step of mechanism, drawing mechanism now. You watch lecture?
I got, but I don't really know. It's not going to be the same.
Okay, good. So mechanism you know, listen now very slowly. So copy first, before 5 seconds. Okay, we copy later. Hey, we copy later. Listen. The movie first. Later, never mind. Can. It's like all lecture in uni. No writing notes, no pen, no paper, no laptop. You see, this is a lecture. It's not a copying. So it's lecture for the whole 10 weeks. No, more. You take out the exposure. Then you see, it's the lecture. You don't know the lecture, right? So you got friends what? Powerful, okay, anyway. Also, bullshit. Okay, come look here. Hey, listen first. Later copy. I give you time. Don't worry. This one start off, Again, can you tell me who is delta plus, who is delta minus? Very good. Okay. Very good. See, never watch lecture, still know, right? Naturally, you should understand things. Then it makes sense. So the Cn minus dot dot will attack the C or the O again. C or O. Because there's weak attack poor, attack like that. Nice. Flow up, hit this guy, and this is called slow. And you draw the intermediate. This time. RCM. Nice. Very easy. Any questions? They must be very natural and you must attack for a reason. Don't memorize things for fun. Then waste time. Remember not? Okay, sure, member one. Okay. But this member with understanding, not member to like memorizing. Later. No, I don't know whether no, that is for the phenol, but later tell you why. Okay, understand this first. Then what happened? I show you, see HCN coming here, right? Who is delta? This is a fast step, that's right, slow fast. Now, okay, delta plus delta minus, it can attack who? The O minus. Very good, right? Naturally attack this. This one, point to the C, don't anyhow. Then we happily get the product already. Then this is just the mechanism. It's quite smooth, I feel. But must understand. Okay, copy and ask me question in a while. This is slow, this is a fast step, slow fast. So Cn, when you involve Cn, whether is it this chapter or halogen, right? The problem is a step up, right? Okay, so you must know, whenever some Cn is involved, it's called step up. Means increase carbon by 1. But the problem, how you know should you step up using carbonyl or halogen? Because I can step up using this thing that we just learned versus my previous chapter, right? How what is something you spot? So I have to see, right? For carbonyl is okay, look here. Maybe you can answer me after I draw out. So carbonyl is like that. Can you spot a pattern? Oh, step up. Right? For halogen, is like that. What's the pattern? How to decide which one? Because increased by 1 carbon, I can go through these 2 ways, right? How do you know which one? I mean, of course, the question tell you, then you know what. But if the question don't tell you, then expect you synthesize something, then you don't know. Right? What's the pattern you spot? Which one? What is secondary? What do you mean secondary? No. What? No. Secondary can be alcohol, is it? No, I can change the H. No. Anything. Okay, listen to me. Okay, go back. So it's not. Listen to me. I tell something. But the sad thing, if I draw like that, people still know what. The sad thing is that they will not draw like that. They will draw like that. It's very scary. So I can tell you now, but you learn. Okay, Lord, I heard before this thing. But you need practice. Then you realize what I'm trying to tell you. You know. Okay, look here, everybody. Hopefully R or something. Okay, so what I'm trying to tell you is that they will skip this part. They won't even tell you. You must know. They want you direct like that. They want you to do like that. And you must know, oh, okay, to come now, oh, that is very ambiguous. Okay, let me tell you this. Very simple. If there's a step up and somehow you spot a OH with a COH, right? It's carbonyl. This guy just COH. This is the main part there. When there's an OH suddenly at that same carbon with a new COH. Of course, carbonyl. Because carbonyl got the OH produce the OH. But if just a step up, then got only an extra new COH, then it's halogen. Means there's an extra OH with carbonyl. That's what I'm trying to teach you. But not only COH, it can be what? CN can be COH, can be CO minus, and what's the last one? CN got 3 destiny, 3 path. What's the last one? Right? Can be COH, can be CO minus, can also be the reduction of CN is what? Reduction of CN can be what? CN can be, from a CN can be CH2NH2 amine again. So if you see, okay, wait, let me draw properly. Listen, but need to practice. I can tell you, but you come to the thing is a different thing. There's OH again. Whenever there's a new group, right? This entire bottom guy is a new group. Whenever the bottom guy appears and there's an OH, it's also through carbonyl. Okay, so your brain please program in a way that when there's a step up, you got to think carbonyl or halogen. When there's an OH, it's carbonyl. When there's no OH, it's halogen. You must practice and can. Okay, give you time to copy in 5 seconds. Our last one is CO minus. Okay, this is draw. So it's just a basic hydrolysis. So instead of COH, it's COO minus. 3 parts. So CN also got 3, yeah. So CN is 3, right? Can be acid hydrolysis, basic hydrolysis, or reduction. Okay. Okay, now I have to go back to the mechanism. Okay, one more than the rest. This one. Second finish. Okay, go back to this. Two of you have learned kinetics, I'm sure. Can you write down the rate equation for this page? Very good. So rate equals to K, the slow step, right? So K, the carbonyl, right? Carbonyl, and your CN minus, not HCN, right? Okay, listen to me now. This part is A level like us. So now I'm trying to convince you that why we need the trace. First of all, HCN is a weak acid. HCN is a weak acid, so there's little dissociation. I say again, HCN is a weak acid, so he partially dissociates very little, very low concentration. Yeah, repeat again, CN minus, very low concentration, weak acid, right? So when it's a low concentration, my rate fast or slow. You see, I need this part, I need this guy to be relatively high, right? And this guy, of course. But now with a low concentration, my rate fast or slow? Slow, because very little, right? So I got to ask for people to rescue me. So first situation or first method or first alternative, I bring in a base, okay, to react full arrow. NaCN and water. Well, NaCN is a salt, so he will dissociate fully. Wow, now a lot there. This is a salt, right? A salt, and it's a sodium salt, very soluble, a lot of CN minus. So I bring in neutralization. It's a full arrow. All neutralization reactions are full, even though it's weak. Strong, weak, strong, weak. So NaOH and KOH is to neutralize HCN. This will result into a salt which will fully dissociate, which produce a lot of CN minus. Okay, say again. HCN where NaOH is a neutralization. Okay? So I produce salt. Salt, and that's a soluble sodium salt. Potassium and sodium salts are very soluble, surely fully dissociate, right? And will produce a lot of their ions. Second alternative, just the salt lah. So I throw in a bit of the salt, it fully dissociate. So there's a lot of Cn minus, right? That's the reason why we add the trace. I repeat again, in this whole entire nucleophilic add, I need a reasonable amount of reasonable concentration or high concentration of Cn minus. Throwing HCN there by itself doesn't help because it's a weak acid. HCN by itself dissociate partially, very little only. Doesn't. So say again. Yes, you can say that way because the Cn minus is being regenerated, right? Right. So to be honest, I just need trace, a bit can start off with it. You see not? Right? Because Cn minus, yes, a great spot secondary, use up later, come back. Use up. So the start better be good.
Wait, for the second one, like you put any Cn, then you get concentration from Cn.
Cn minus ions will be a lot because NaCN is fully soluble, right?
You don't support you Cn.
Only for this part, no choice.
But then you also can be any class. I mean, anything you have to talk about Cn.
No, because my O minus also, I need to link the HI.
Oh,
okay. I said, but they never asked it before, but that's the reason. Okay? I don't know whether your school, I know I put H plus, that means they say you get third alternative. No, yes, it's very funny. KCN in dynamic H2SO4. I don't know whether the school have or not. Then to form the H plus with the O minus. But the school doesn't know bother. This is the main one. They ask you why, A level ask you why. Let's get this right. A lot of students after a while, when do TOS, also still cannot get it right. Very funny. Okay, so that's the idea, right? To have reasonable amount of concentration of Cn minus. Cn by itself, very bad because it's a weak acid. How to test for carbonyl? How to test for carbonyl? How to test for carbonyl compounds? We need to know. So we use our good friend called what? 2,4-DNPH. Many students don't know how to draw because they don't know the name. So can you write the name down? There is different colors. See, good. Nitro, phenol, right? Phenol, hydrazine. So nice. Please learn the name now forever. You can remember the draw? Okay. Hydrazine formula is N2H4. So hydrazine is N2H4. So you draw a hydrazine first. Okay, everybody, yeah. Okay. Anyway, you take away one H because I need to connect to some benzene later. Okay, so this is your hydrazine.
So you need all the forming CL, I mean PCL, like the
Form water, condensation. It's a condensation reaction. Okay, but you see, but what I'm trying to teach you now is to draw the thing out. A level, long time never asked, I think, but can ask, right? It's in syllabus. Phenol is a benzene ring, not phenol. Phenol and phenol totally different. Phenol. But I recently I never see it coming out for exam, but I think it's good. I mean, talk about A level, okay, also I'm not sure. But I think it's important to know in case. Nitro, right? So dinitro is 2 nitro on the second and fourth carbon. So can you see if I break it down, no big deal.
So what is this?
Which one?
What is this?
Hydrazine. So hydrazine is N2H4, but I take away one of the H because I need to connect to a benzene ring. Right? Then on the second and fourth, I put a nitro group. You understand?
It is at the end, isn't that the substituent?
What do you mean? Oh, the hydrazine word.
Hydrazine is
The main one.
So it's on the first carbon. So the
2,4 comments. So why is it a test for carbonyl? Carbonyl is made out of wood. And yes. So you see, My carbonyl is here. Okay, look here. Any guy, LD or ketone, depends on whether got HR. Now, circle out water. Wow. Circle out water. So this is called a what? Condensation reaction. What? I don't know why. Lots of people don't know. I the teacher just anyhow teach fast. I think it's an easy thing, you know. Circle out water. So your product got water lah, because condensation you produce more molecules. Not necessarily water can taste here, but for this case, water. Then you hardworkingly join both together lah. What's the difficult? NO2 like that, like that, like that, like that, like that. NO2 NH. Join together. Just now got double bond, then put double bond back. Because carbon need to form 4 bond, nitrogen 3 bond. Right now. Right, so you got water and you just drag them together, you understand? And this guy is a what? Orange. Finish. Very nice. Correct. So, but it tells you it's a carbonyl, but it doesn't tell you is it aldehyde or ketone. You know, that's a problem. Can, but at least you know carbonyl. So today can draw this, can break it down, join together. Orange PPT means there's a carbonyl group present. Okay, finish.
Carbonyl is CO.
CO. What do you mean? Then CO. C-double-O. Carbonyl group is this one. 这边是一个 carbonyl group. 这边 is called carbonyl group.
Wait, then acyl is what?
Okay. Cannot. Good question. So carbonyl must be either R or H. Another acyl chloride is a COCl.
Oh,
So acyl chloride cannot do this. Strictly carbonyl. Like ester also CO, right? Carboxylic acid CO, you know, COOH. Cannot no count. So that's always a trick in exam. People see this CO, they excited. Oh, I remember the teacher said this before. No. Must be strictly a R or H. And 30 small. Yeah, move on. Okay. So this only test for aldehyde ketone. Don't know. So now we got to go and find out. Okay, tell me, if I give you aldehyde ketone, how do you differentiate? Now I give you one container, one test you aldehyde, one test you ketone. How do you distinguish? Hey, what? You didn't learn it. Not put KML 4, put CL 7. Right? Because who can oxidize? Who can oxidize? Aldehyde or ketone. Okay, wait. Aldehyde ketone. Yes. Ketone can aldehyde can oxidize the form. Aldehyde can oxidize the form. Aldehyde can oxidize the form.
Alcohol, then
No. Alcohol, aldehyde, carboxylic. So aldehyde can be oxidized to form carboxylic acid. Ketone can? So actually you already know, but there are more methods now. You understand? So you said it correct. So because of this, very irritating. I can't remember the exact things, but at least some stuff is Tollens, right? Reagent. Listen to me, and Fehling's solution. I can't remember the equation, to be honest. I really cannot remember. I struggle to remember, but whether you learn actually need once a while they test for the 1 mark. But I mean, it's good to know. Maybe nearer at the exam, you try to find a way. I always forget. So I show something first. Wait. So what happens is that Tollens reagent and Fehling solution. Can you remember the result? If there is a positive test, what happens? Silver mirror observer. And the bottom is what? Depends on school. Brick red precipitate or reddish brown precipitate. Brick red precipitate. Brick red PPT. Okay, follow your school. Some silver mirror, some shiny silver mirror. Basically, a silver solid is formed. Okay, now. Wait, I see. I struggle always. So this is I think it's an alkaline. Different school put different thing. Alkaline solution of copper to tartrate. Okay, don't worry so much. I also can't remember what is it. But at least you know that this thing occur, and this is a ammonical solution of silver nitrate. Okay, different school really put different, but at least you know something like that first. The exact reaction nearing A level we analyze, okay, or June, okay, during holidays. Okay, I tell you, it looks very weird. Tartrate, Tartrate. Alkaline solution, both are alkaline. Ammonical is ammonia, ammonical solution of silver nitrate. Okay, if I'm not wrong, yes, it's Ag, I can remember it, NH32 plus. This is like the main ion. And this part here is like a Cu2 plus ion. Okay? Okay, something at first. I teach you the idea. So when it's a positive test, Ag, you know that guy there, the complex there, what's the charge of Ag? +1, right? But ammonia, no charge. Later, he formed Ag. So what happened? Oxidize or reduce? So what agent is this?
Oxidation.
Can you see? I teach you like that and hopefully you get the idea. Right? So these two are oxidation agents. So these two are oxidizing agents. So he can react with aldehyde or ketone. These two are oxidizing agents. So both of them can react with aldehyde or ketone. If there's a positive test, this one is positive test. I show you, I can see, positive test. So you think, you need to tell me the answer. Okay, then I say aldehyde, ethane how? If I say again, both are oxidizing agent, so they should be able to react with aldehydes or ketone. They are both oxidizing agent. Say again. Yeah lah. If you understand this, okay, what? Okay, but don't write so fast first. Don't write so fast first. Right? If you understand this, yeah, okay. People don't understand this, right? But okay, this one I don't know the reason. You just accept it. All aldehydes. Tollens reagent can react all aldehydes, but Fehling solution cannot react with benzaldehyde. You know benzaldehyde? Benzaldehyde means an aldehyde group with, a benzene ring with an aldehyde group directly attached. I say again, this is called benzaldehyde. The aldehyde group is directly connected. This is also called an aromatic aldehyde. Okay, sidetrack a bit. This one can or not? Can this react? The yellow one? Can, right? It's not an aromatic aldehyde, but it's an aromatic compound. There's a benzene is aromatic, not aliphatic. So aromatic compound can, but it's not. So this one, this is not that. So I take a bit. So Fehling solution can react with all aldehydes except benzaldehyde. Can? Fehling is what? F word. F word sucks, right? F word is bad, so it's lousy. Yes.
So for R, like, is
what R?
No, like as in like the
alkyl.
R is alkyl.
C.
Then, but the benzene is also counted.
Yeah. Yeah, can also. Oh, I feel uncomfortable to answer you. Yeah, should be lah. And then basically it's carbonyl benzene or carbon. Yeah, then one more. Thank you very much. You learned this before, right? Thank you very much. Can you draw the version for the which chapter? You don't forget. Again, what chapter? You learned before this, definitely. Thank you very much. Can you draw the hydroxy version? But how can you forget? Okay, maybe you can remember now. And this one, the carbonyl version. So, triiodomethane test apply to both hydroxy and carbonyl. A certain structure fixed like that one. Then there's a positive test. Try to recap them. Learn it properly, right? So this is compulsory and fixed. Don't change it. Okay, so the other group that doesn't matter is the bottom, I mean, one of them. So, but this one is compulsory, got to be like that. But I told you before, I believe, this one can be CH2I, weird one, can be CHI2, can be CI3. The top group can. The mechanism is not in A-level syllabus, but I see questions more towards prelim lah. Putting the CH3 to be all this also can lah. The bottom, I don't care, can be H, can be R, doesn't matter. It's the top that is fixed. Okay, today for this chapter, another fixed guy. Okay, the bottom, I don't care again. Fixed. Same thing on top, can be CH2I, CHI2, same lah as just now. You see now. Fixed. Okay, so if there's a positive test, yellow precipitate of CHI3, can? Okay, so don't be confused. That was orange. 2,4 DNPH is orange. Now this yellow. Okay. This reaction name, in case they ask you, is called what? Oxidation. Very strange, but can you just accept it? The mechanism not in A-level, but this also oxidation. And strangely, if you do more question next time, now maybe I tell you, just okay, it's a step down. You know why? The CH3 group gone later. Right, so this is a step down by 1C. Yeah. Okay, important. Yeah. Okay, very good. For carbonyl, right? Any questions? For carbonyl, right? There's oxidation. That one I won't teach because that is taught in hydroxy. It links to that heavily, right? So it's still like that. So I believe this entire thing, what's the little? Let me think whether I miss out anything. What's the second one? 2,4 DNPH, Tollens, Fehling, Triiodomethane. Yeah, it's just like that. Oxidation of an alkene, Y gives a diol. Further oxidation gives a diketone. Wow, very obvious now. So diketone, diol means 2 alcohol, right? Diketone means 2 ketone. So very obvious the alcohol is what? 2 secondary alcohol, correct? You understand? You understand? 2 secondary alcohol. So we just try one by one now. So first one, if I put the OH and the OH, is it secondary? No, this one primary, right? Wrong already, right? Can you see now? The right side should be a primary alcohol, one R group only, right? Can you see when double bond break? You think can see? Second one, I put the OH and the OH. Oh, nice.
Yes. Oxidation, that's really strong solution.
Yeah lah. Otherwise, it will not be a ketone. Okay?
But then it is diol, and then you do it from there, then you become the OH will become double bond.
For which one? Oh, that's correct. That's mild. So you need strong. Yes.
Like if you see mild, right, you do mild first, and then after that, then further oxidation.
Yes, correct.
So then is that alkene strong oxidation, or is that diol?
No, diol is mild already.
Yeah. So it's
Mild oxidation
oxidation
of
of
alkene. Mild oxidation of alkene first. After that is strong oxidation of the normal alkene. When it becomes a diol, normal alkene, double bond break, double bond becomes single. Remember? So the further oxidation of the alcohol. Okay. So what's the answer? Yeah, straight actually B, need to continue because both are secondary, right? This is a secondary alcohol, this is a secondary alcohol. You see now, you see, if you do the next one, tertiary, wow, right? Draw out to be convinced. So this one is a secondary, one secondary, one tertiary. If this is a OH, this is a tertiary.
Then the ketone looks like what?
Oh, so the ketone look like what? So C, 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 double bond O, double bond O. Nice. Can see now? Diketone. Okay? Still not bad, huh? Still doable, right?
No, I thought it was strong.
For which one?
Like, I thought they were talking about strong oxidation, so then you do it for one.
Oh, strong oxidation will not give you diol. Strong oxidation will chop and then no diol.
Yeah, I thought
You understand? Okay, let's proceed. React with this compound. Who react? Who react with this compound? Okay, now see one by one now. Lithium aluminum hydride is a reducing agent. Can reduce anybody or not? Again, can reduce anybody? Can you reduce anybody here? Can. This one is a ketone. Correct. Ketone can be reduced to secondary alcohol. Remember, we remember the thing? Secondary alcohol to ketone, ketone to secondary alcohol, right? Oxidize and then reduce, right? How does it look like? Draw like that, OH, then secondary alcohol already.
and then you will become H for one.
Yes, so the bottom got one more H, right? Not A, but I'll check the rest. Understand not? One more time. Remember, secondary ketone can be reduced, right? Sorry, secondary alcohol oxidized to ketone, right? So ketone can be reduced to secondary alcohol, left to right. What's the concern? What's the what? What's the second one? Oh, there. One R here. Like don't know what one R here. The ring. No. I mean, yeah, it might need the ring, but it's just 2R. As long as bond to a C is R. You see, there's a C here, there's a C here, right? It's R. Don't care what happens. Okay, so I assume there's A lah. Let's check the rest. Okay, I need to delete this. Now I can't really see it. Good. Check the rest. Concentrated sulfuric acid. Cannot lah. What is this used for? It's a dehydrating agent or addition of water, right? To alkene, remember? Right? If the different condition, right, in the test, they ask you, right? So excess concentrated sulfuric acid, heat, then you take away water, right? Dehydration. From alkene, right? Elimination. Or you put water in, it's co-concentrated, it's used for. Alkaline iodine, triiodomethane test. Oh, John, I didn't tell you. So this triiodomethane test, right? This is a triiodomethane test. Okay, triiodomethane test. Don't have. Where got? They probably put a CH3 very sneaky. Don't have what? Don't have the two structures we draw just now, right? Last one, oxidize. Cannot oxidize anything. Hey, hold on. I'm very scared. Hey, this one funny. Why like that? Acidified potassium manganate 7 can you can you see there's at least a H here? There's a H here also. Hey, how come 2 answers? Can also. Weird. Benzylic hydrogen, or there's a benzylic hydrogen means the carbon connected directly has at least 1 H. So it can be A or D. You know what's the meaning of benzylic hydrogen? The carbon that's directly attached to the benzene ring must have at least 1 H. Right? So end up, if this thing takes place, you know what happens? You form this COH, COH. That's it. The rest all the cough. You know what? Wrong question. Both can. A and B can. Okay? Yeah, so such an oxidation of benzene. Yeah. That's right. Final product obtained when the alkene below is reacted with right. So co-alkaline. Co-alkaline straight away. I don't waste time to OH first cannot. OH, gone. Followed by hot acidified potassium dichromate 6. Right. So hot acidified potassium dichromate 6 weapon oxidize, right? So the first one remain the same because it's a tertiary alcohol. Can you see that? Is it tertiary or not? 1R group, 2R group, 3R group. So it must remain. So B cannot, A cannot. Then the other guy is a what alcohol? Wow, this guy is a primary alcohol. So it becomes a COH. D. Not aldehyde. Like, aldehyde is not hot. Aldehyde should be warm with immediate distillation. It's actually, all this is what I taught you, right? This just apply to the question, right? Okay, so which of the following could be W and X? Do what? Or to form that, it may be ascending form W using X. Okay, so we do one by one. So the first one is about what? KOH ethanol. That is your elimination, right? Wrong, because elimination of HX. So for this case, HCl. So I should have a Cl gone and the H here gone. So I should have a new double bond. Do you understand? Can you visualize? KOH ethanol is elimination HCl. Concentrated sulfuric acid over here, concentrated sulfuric acid at 170 is your elimination of water. So it will take away the H. Oh, it take away the OH. And yes, and there will be double bond also in here. Right? So you have a double bond, double bond, but it's not right. Right? So you need to know elimination of HCl and elimination of water, these two will form an alkene. It's the only way to form alkenes through elimination. So A and B not right. Wait, you can understand not? So whenever you got this, you form a new double bond, but from the product to from the reactant to the product, no new double bond. I mean, okay, have the bottom part, but the bottom part form two double bond. So elimination is your adjacent HCl or your adjacent water. Equals NaOH. Do what? Just now we learn, right? Suck the Cl, put OH. Correct or wrong? Wow, correct or wrong? Wrong. Why? Well, looks very correct. I want to say correct. Why wrong? Why wrong? 1 C less. So answer is C, right? Whereby this is an aldehyde, right? I reduce to form a primary alcohol. That's it. This is an aldehyde, right? So if you say how to visualize it, the aldehyde, right, will reduce to form a primary alcohol. The CH2 OH. Okay, must practice then you can visualize. So this is quite a good question to analyze things. So I don't think it's a H1 question, it's just that maybe this school feel that H1. It's just normal. Don't bother about the bottom. Okay, let's go. Ethanol. Wait, what's ethanol? Ethanol is this. I forgot to tell you the name just now. So ethanol is an aldehyde. Known is a ketone, like proper known is a ketone. Now is an aldehyde, known is a ketone. So what is happening? So I don't know, I draw out, right? So CH3, C double bond O, H. After that becomes what? Not tough, Okay, what happens? Okay, so that's a CH3 part, never change. Yeah, so this part is still CH3. Okay. Wow! Application to the max. What's the answer? Okay, yes, nucleophilic addition, right? Even so, that's so sad. Even though just now I told you that okay, one variation HCN, but it can be like that. Can you see it feels like the HCN problem? Right? So you must really practice. This is what I'm trying to say, application coming. Totally not something you learn in the notes at all. Right? So nucleophilic addition is where the double bond of the O break from an OH and new guy coming. Okay? Last one. It's so easy because they hint to you a lot, especially they say this word, right? Especially they say carbonyl compound. Wait, Ethan, what's the answer? Yeah. Correct? What's so difficult? Okay, what? Not too bad, right?